All right, so this one says, given f of x is 3x minus 1 and g of x is x squared minus 4, find the following and include the domain restrictions. So with number 1, we want to add the two functions together. I'm just going to do 3x minus 1 plus x squared minus 4, combine my like terms, so I get x squared plus 3x minus 5. Domain restriction, remember, if you are using them at the beginning, they carry down if you're adding, subtracting, multiplying, all that stuff. So I would come back up here just because it's easier to check it at the beginning. This is all real numbers, so negative infinity to positive infinity. And so is this. So there's no domain restrictions on my original functions. And there's no added one on number 1. So I'm going to say that the domain here is negative infinity to positive infinity. You always got to check original and what you made. Number 2 is minus. So 3x minus 1 minus x squared minus 4. That minus goes to both terms. And I get negative x squared plus 3x plus 3. There's the difference of those two. And then again, there was no domain restriction at the top. There's none brought down, so my domain is again negative infinity to positive infinity. Number 3 is the division, right? So we do the top divided by the bottom. So 3x minus 1 over x squared minus 4. And that can't be simplified. My original restrictions are negative infinity to positive infinity, but we just added one because we put a variable in the denominator. So if x squared minus 4 cannot equal 0, then x squared cannot equal 4, and x cannot equal plus or minus the square root of 4, which means plus or minus 2. Now we have two things that our interval notation needs to skip. So the way we write that is negative infinity to the first one, which is negative 2. Union first to second to negative 2 to positive 2. Union positive 2 to infinity. So when you have two not equals in your domain, this is how it's set up, okay? From negative infinity to the first one, then first to second, then second to positive infinity. So that happened because we put G in the bottom. My kids just asked me if I had property brothers working in my room. It's so pretty though. Almost done. All right, number 4, we take the negative 1 and plug it into the G, and then take that and plug it into the F. So I'm going to do negative 1 squared minus 4, 1 minus 4, which is negative 3. And then I do F of negative 3. So I do 3 times negative 3 minus 1, negative 9 minus 3, which is negative 10. So that's the result of F of G of negative 1. The domain on the G was negative infinity to positive infinity, and I took that one and plugged it into the F. So that's what I would have to bring down. If I did have one, you bring down the one on the right, and this, it would be, domain would also be negative infinity to positive infinity. Yes, other way around. So that's, you would do, so that's what 5 is, right? 5 says G of F of negative 2. So I would do, change the color here. I would do G of F of negative 2. I'm going to plug negative 2 into the F first, so I go in here. 3 times negative 2 minus 1, negative 6 minus 1, which is negative 7. And then I find G of negative 7, so I plug that here. Negative 7 squared minus 4 is 49 minus 4, which is 45. And then you want to look at the one on the right, right? So just like we did the one on the right here, that's the one we're plugging in. If there was a domain restriction there, I'd bring it down. But because there's not, the domain here is also negative infinity to positive infinity. Questions on those? So let me go through the homework. So I think I have Isabella's first. No, that's a lie. I have 7's first. This is 3D, right, which said to find F over G of X. So you left it like as two fractions, which WebAssign didn't like, right? You have to simplify it. So when I get, which is this, I think this was right. I cut off the beginning, so let me see. F was in the top, x squared minus 9 over x g of x squared plus 1. That was, the setup was right, but then you had to keep going. So I, from there, would do keep, change, flip. This is my denominator, so I keep the top, change it to multiplication, and then flip. And then I would have gotten x square root of x squared minus 9 times x squared plus 1 over x squared. So it just wanted you to keep it, you can't leave it complex fraction as an answer. You had to simplify it a little bit. You're on the right track. Just didn't keep going. And then number 4 said evaluate the function f minus g of -5. So you have two options, remember, is -9, sorry, is find f of -9 and then subtract from it g of -9. Or I can combine the functions together first, f minus g, x squared minus 1 minus x plus 9, and then plug in your -9. Either way, you should get the right answer. So I'll work through both. F of -9 is -9 squared minus 1. That's 81 minus 1, that's 80. And then g of -9 is -9 minus 9, which is -18. 80 minus a -18 becomes plus, and that becomes 98. That's the first way. The second way, if I take and simplify this, and then plug in a -9, 81 plus 9 plus 8, 90 plus 8, which is 98. So it doesn't matter which way, if you want to combine your functions first and then plug the value in, or you want to plug the value in and then add them. You could do it either way. The times you can't do it either way is like when you have that fraction, right? When you, when you have a graph. When you have a graph, you have to do them separate, which was like the notes. I think I have Isabella's. So number 3, domain of f over g. The g is in the bottom now, right? So when you simplify it, which this is it, when you simplify it, you should have gotten that. But now we put the x squared in the bottom, so x cannot equal, x squared cannot equal 0, and x cannot equal 0. But you also have the beginning, x squared plus 1 cannot equal 0. Wait, did I do that right? G's in the bottom. Yeah. And so then x squared cannot equal -1. That never happened. So this doesn't happen. And then it should be 0, f over g. Oh, x cannot equal 0, but you also have your square root. X squared minus 4 underneath the square has to be greater than or equal to 0. So we go back to our test points, plus and minus 2, -2, +2. Remember the one I said you were going to hate, right? But we did it together. -3, if I plug it in, I'd get 9 minus 4. That is greater than 0. Plug in 0, it doesn't work. Plug in 3, it does work. So from there, I get -infinity to -2, bracket on the 2, union 2 to positive infinity. We need both of these domains to be true. So if I graph it on a number line, the top one is this. The bottom one is just that it cannot equal 0. So if I keep the top one, it already eliminates the 0, which is why I don't even have to worry about the 0, and I just pick the cannot equal, or has to be less than or equal to -2 and greater than or equal to +2. So I mean, I said it when I taught it, but those like inequalities and quadratics probably not going to be on your set. Other one? No. 8. 8 also domain f of g. So I have to look at if there's a limitation to g, which there's not. That was all real numbers. But then once you find the composite function, so once I take g and I plug it into f, now I have to see if there's a restriction there. So this has to be greater than or equal to 0. X over 3 has to be greater than or equal to -4 multiplied by 3. And x has to be greater than or equal to -12. And that's where that domain restriction comes from. Number 5. Sorry, I think this was yours. It's f times g of -4. So you have two options again. I can do x squared minus 2 times x minus 4. Foil that out and then plug in the -4. Or probably easier this time is find f of -4. So -4 squared minus 2, which is 14. find f or g of -4 minus 4, which is -8, and then do 14 times a -8, where the -112 comes from. Any other questions from the homework before we get into the review? No, not when you're multiplying. It doesn't matter, right? Because the order doesn't matter. If it was subtraction, you can plug them both in, and it doesn't matter which order you plug them in. But you want to make sure you do the subtract the g from the f. That's all. Just pay attention to that kind of order. Okay, we are going to build this together, and I'm going to collect it at the end, okay? Which means you need to, either if you're sleepy, if you're doing something that's not productive, you need to wake yourself up, you need to get yourself together, you need to open up. You can do this on a piece of paper, or you can do this on Notability. I don't care which one, but we are going to build a reference sheet for your test together. Now, this is not going to have a bunch of examples and that kind of stuff. That's what the homework's going to have. What this is going to do is review the concepts in each section and what you need to know from each section. My goal for you is to have one paper, or if you write really big, that's okay too, but maybe 2 papers that cover all this concepts. I don't want you to be digging through your notes. 1, you won't have time, okay? I promise that if you keep going back and forth between your notes and the questions, you will run out of time on Thursday's test, okay? 2, this should be hopefully an easy way for you to look at all the content in one space. Okay, so I'm going to start, like I just split it up. This is just how I split up. Doesn't mean you have to split it up the same way, okay? But I start with obviously B1 and B2, okay? Overall concepts for, or guidelines for your test are going to be 2 devices again. First device, logging into Zoom. Second device is going to be your iPad for the actual test. And your notes. You can have notes. You can have hard copy notes. You can have hard copy scrap paper. You can use Notability for scrap paper. This time you have to have a calculator because you're going to be graphing. The section 1.3 is going to have that graphing on it, which means you can either use the handheld or you can use your app. Okay, I don't care which one, but make sure that you have all that stuff ready to go. If you're using a second device, like if you have a backup iPad or something like that, and you're using that to take the quiz, or you're using your computer to take the quiz, just make sure you still have access to your calculator, okay, or to a graphing utility. All right, so I'm going to start with B1. B1 was circles, distance, and midpoint, okay? So we started with a couple of formulas here. The midpoint, which is x1 plus x2 over 2, y1 plus y2 over 2. Distance, square root of x2 minus x1 squared plus y2 minus y1 squared. The equation for a circle, standard equation, x minus h squared plus y minus k squared equals r squared. And then this is also where we classified our triangles. So if it's a right triangle, then a squared plus b squared would equal c squared. If it's isosceles, 2 sides the same. If it's equilateral, 3 sides the same. You want to remember to simplify your radicals in this section. So if it asks you for the distance of something, you want to make sure that that's always simplified. B2 was our graphs with our like X and Y points. Obviously, we're not plotting points, okay? But you also had graphing with the T-chart. So if I gave you something to graph and I asked you to fill in the chart, you did that on the quiz, same kind of concept. Intercepts. The X-intercept you get by plugging 0 in for Y. The y-intercept you get by plugging 0 in for x. You are going to put these in coordinate point form. Okay, otherwise it will mark it wrong. So you're not just giving me numbers there. Intercepts would be in the coordinate point form. Then symmetry came from this section as well. X-axis, the test is to plug in, change y to a negative y. Y-axis, I don't know why I put an arrow there. Thank you so much. Awesome. Thank you.
Right.
You change x to a negative x, and origin, you change both. And then if the equation equals the original, or every term left and right of the equal sign is the opposite of the original, then it's a yes. Questions on 2, B2. Anybody still coming it down? Yeah, okay. One was graphs of lines. So you had where you were actually graphing the line, you had where you were finding the equation, the slope, all that good stuff. So you want to make sure you know how the slope. There. The slope intercept form of an equation, so that if it asks you for an equation, it's not gonna, it may not say it in slope intercept. Remember, that's the default. Okay. The point slope y minus y1 equals mx minus x1. And then standard, in case it gives it to you, ax plus by equals c, no fractions and decimals, and this one, the slope is, you can get the shortcut, negative a over b. You would want to be able to graph the line using the slope and the y-intercept. You would want to be able to find slope. So remember slope, y2 minus y1 over x2 minus x1. And you would want to be able to, what am I missing? Oh, parallel and perpendicular. Parallel lines, same slope. Perpendicular lines, opposite reciprocal. Questions on 1-1. So that's one of your graphing questions where you're going to take a picture of your graph and you're going to upload it as that answer. Okay, there are going to be a few like that. That's one of them. Yes, I. Which letters? Yeah, so the M is the slope. The B is the y-intercept. So it's technically 0B. This one you plug the point in. Point is x1. y1, m again is the slope. And then standard, there's no special, like it's just that they're all whole numbers. and the x has to be positive. Yep. What? Oh, like where did they get the letter B from? No clue. Sometimes I feel like mathematicians get drunk and try to mess with us. I'm not really sure, okay? They just were like, hey, B looks good. Let's pick that one. And then let's use a capital B in the standard form, which is not the same B, so don't confuse that because that's not the same B, right? They just like to mess with us. Maybe one day I'll ask Siri that question. We don't have time today, but maybe one day. Okay, then everybody good on 1-1? Remember that you'll be graphing the lines, graph lines. Okay, then 1, 2 came the functions, and we started with the functions from the equations. So we started with the functions using domain. We did, hang on, let me change the color. Okay. Domain from a function, which is x in the denominator, right? All reals, or negative to infinity to positive infinity, except variable in the denominator. And for this, we set the denominator not equal to 0, variable under a root. And for that, we say what's under the square root has to be greater than or equal to 0, variable in denominator under root. And for that, we say whatever's underneath the root has to be greater than 0, can no longer equal to 0. All of that will be in interval notation, which your instructions will say, you know, provide your answer in interval notation. Then it asks, is it a function based on points? X repeats, let me spell repeats right. So if I'm looking at an equation, if I'm looking at points, the x can't repeat with a different y. And if I'm looking at an equation, y cannot be raised to an even power, or y can't be an absolute value. That's when it's not a function. All other times it is a function. So you will get one question that is simple, yes or no, is it a function? And it either will be the points, the equations, or a graph, but that's basically how you would do either of them. Okay, we had evaluate a function in this case. So if I had f of 2, remember this is where we plug in. We also had piecewise functions in here, like where you had to figure out which part of the piece to plug it into. The graphing didn't come till the next section, but and we had difference quotient. Which is f of x plus h minus f of x over h. So remember, we do the f of x plus h, we do the f of x, subtract it from that, make sure you change all the signs on the f of x, and then you put it all over h at the end and you simplify it. Things should cancel out. If you have one big, full, messy equation, you did it wrong. But do not get stuck on this question. This is early on in the test, and if you spend too much time on this question, you will not finish. So you need to make sure that you allot the right amount of time for these questions. If you get stuck on this question, move on and come back to it. This one is, I think it's 10 points. It is one of the ones that has a little bit more points. Yes. Yeah. So if you saw an equation that said x equals absolute value of y, that is not a function. You're welcome. That would be a v turned on its side, which fails the vertical line test, which is the third test, but that was when we got to graphs. That was in 1.3. Questions on 1.2? Okay, then came 1.3, which was the graph. So this is the big question that is based on, solely based, almost I think, all of 1.3, is that big graphing utility question. So it's gonna ask you to graph a function on your graphing utility and then find all the parts, okay? So the graph is gonna be on the graphing calculator, okay? Then it's gonna ask you to find the domain and range. So remember, domain is left to right. Range is bottom to top. And since these are on a graphing calculator, you're not going to have open dots, okay? Open dots would be parentheses. The rest of these would be brackets with the exception of infinity, right? Infinity will always have a parentheses. If the arrows point left and right, it's going to be negative infinity to positive infinity. If the arrows point down and up, it's negative infinity to positive infinity. This is where it will ask you for your zeros, which is where it crosses the x-axis. And we list these like negative 1.6 and 2.1, like that. You list the x values. This is not the same as an intercept. This is where you go to your second calc menu, like your second trace menu, and you go zeros. You go to the left of it, you go to the right of it, you let it guess, you do the next one, okay? These will be a list. And there is one in the review. The last question in the review goes through all of this. Then you get max and min, right? So relative, I should rewrite it, relative max and relative min. This is each peak, each dip. These are in coordinate point form, but you will also, like if I say give me the max and there's more than one, you'll list them by coordinate points. If I say give me the min, you'll list them by coordinate points, and it says to round them to the nearest tenth. And if there is none, it says put DNE, just like the WebAssign did. So it does not exist, you would put 1. If there's no max, you put no, DNE. If there was no min, you put DNE. Then you had increasing, decreasing behavior. Okay, and this is also in interval notation. And just the x values, because we go from left to right. So every time it's increasing or every time it's rising as I move from left to right, that part of my graph is increasing. If it's decreasing, then obviously it's falling as I move from left to right. Yes, interval notation. Yeah, sorry. Oh, let me change that then. Yeah, no, interval notation. And then we had even, odd. Neither. Okay, even is symmetric to the y-axis, odd to the origin, and neither is neither. The other thing from this function was graphing, from this section was graphing a piecewise function. So this is where it would say, like, if you know, f of x equals this, if it's less than or equal to 0, this, if it's greater than 0, that kind of thing, and you have to chunk up your graph. So that's the third upload. No, sorry, that's the second upload question. The one is the lines. This, the graphing the piecewise is 2, and then the transformations is the other one. For the function one, the big one, like this is all one question. That one you'll take a picture of your graph. Man, that's so ugly, but you get it. You take the picture of your graph and you'll include it on your work, but I'm not actually asking you for the upload of the picture. I can't. I have to just make it all, you know, fill in the blank or a file upload. You can't do both. Questions on 1-3? I think we're... It's probably not going to be obvious. Yeah, I kind of made it so it's not obvious. You want to you mean when it asks for the left bound, right bound? Yeah. So there is one question like that on the review for today that you want to practice, but tomorrow we're gonna do that question together. I'm gonna make you graph it and you're gonna submit it, and so that the format of that is good. And so I will walk you through that whole process. Okay, like we won't have time to do that today, but I will do that tomorrow. Okay, you're welcome. Yeah, so you, on a graphing calculator, you're not going to be able to get the constant part. So for this question, you won't see it. If I gave you a graph and there was like that increasing and then like the flat line and the decreasing, like that obviously would be part of it. But spoiler alert, you can't, like I can't give that to you on a function. It's not, it would have to be piecewise, which I didn't teach you how to type that into a calculator. So yeah. Okay, so 1-4 is your transformation. So this is where we had our parent functions, and then so let's start with parent functions. X squared, which is your parabola. Absolute value of x, which is your v. Square root of x, which is the half the parabola turned on its side. Cubic function points up to the right, down to the left. What am I missing? 1/x is your reciprocal function. It has two little curves, top right, bottom left. Cube root. So then from there, it's going to ask you to do all the transformations. So I'm just going to write it in terms of quadratic, but they are the same for each one. So if it was f of x equals the plus or minus a x minus h squared plus b. Actually, there's a c here. No, yeah, I'll talk about it. Okay, so the plus or minus is going to flip it upside down, right? So positive points up, negative upside down. The a, if it's greater than 1, it's narrow or stretched. If it's in between 0 and 1, it's wide or shrunk. It's a C. It's a C. I know it's funny. This is your horizontal. Stretch or shrink. So it's a stretch if it's less than, and if it's greater than, it's a shrink. But a horizontal stretch is just like a vertical shrink, and if it's that's where it's confusing. They basically mean the same thing, okay? Horizontal stretch is the same as a vertical shrunk, and the horizontal shrink is the same as a vertical stretch. Let me add on here too, if I was talking about a square root, I would say that this is tall and this is flat, if you're talking about a square root. The H is your horizontal shift. Positive, it moves left. Negative, it moves right. And the B is your vertical shift. Positive, it moves up. Negative, it moves down. The only other thing is if you had something, a negative underneath, whether it's with the square root or it's with another function, but it has a horizontal shift. This points at left, and this changes that to a right shift. So there are questions, obviously, on the, here's your equation, graph it, and then also here's your graph, give me the equation. And then we got all the way back up to where we started the day, which was our composite functions, right? So for these, you would have f plus g of x, f minus g of x, f times, that doesn't look like a minus, f times g of x, f over g of x, f of g of x, or g of f of x, okay? And then we also talk about the domains here. Remember that if it's part of the initial, it gets carried down for the individual parts, but if it's part of the initial and it's a composite, so for composite, only carry down the function on the right. And then ask yourself if there's an initial domain restriction based on your resultant function. That's it, folks. We made it. Man, it is 8:55 on the dot. That's a good day, in my opinion. All right, I am opening up an assignment as we speak that has the submission for these notes. You either need to send the whole note file if it's a PDF, if it's one screen. If you got it on one screen, that's fantastic. What is today's date? Today is the 8th. Review. I'm going to call this a review reference sheet. Yes. 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 Yep. It normally goes to the left, but if there's a negative on the front, it flips it over the y-axis, and in doing so, it changes the direction of it. Does that make sense? Okay. You're welcome. Okay, I'm going to put 9. All right, you should see, it just says today, like 9-8, classwork 1, review reference sheet. So again, either submit the whole file or screenshot whatever it is you need. If you were able to get it on one page. If you weren't able to get it on one page, then you're submitting that file. And this is what I would use. I know it's teeny tiny, but this is what I would use if I was going to complete my review tonight. I would only use this reference sheet. And then that helps you know I can't dig into my notes. I don't have time. But if you do need something to remind yourself, like when you're doing it, you can obviously add to it. But my advice is to try to keep it as minimal as possible. All right, the review is on another assignment. It is, it's marked as non-graded because I put all the answers. So just make sure you follow directions. There's 2 reviews there. If you want to work on one tonight, one tomorrow, that might be a great idea. Tomorrow in class, I'll go over questions on the review, and we'll also do like a practice question on that graph. All right, folks, have a great day. Make sure you get those notes submitted.